Alright, so we are doing indirect measurement, and this all is kind of a build-up from our similarity ratios and similar polygons, and we can now put it all together in real world applications. So oftentimes you will see these as blueprints for an architect or an engineer. They're all coming together, the construction workers looking at these blueprints to decide how to build whatever they're working on. And so, just as a reminder, we have similar polygons. Those have the same shape, but they have different sizes. So the same shape is where corresponding angles are congruent, and the different size is where those corresponding sides were proportional. And we can use these similar polygons to help us with indirect measurements so that we can find lengths of buildings that we wouldn't normally be able to measure with a ruler, or if you're far away from something. This is what surveyors do often, would be a picture like this, and they actually use trig and all sorts of cool stuff. Question: how many seconds are in a year? There's 12. January 2nd, February 2nd, March 2nd, and all the others. Alright, so enough with my nerdy jokes. Back to our indirect measurement. So on here we've got a small triangle inside of a larger triangle. And we're going to solve for some missing parts. So I want to set these up in corresponding orders. So if I am going to compare my little triangle is to my big triangle, I could say little triangle base is to little triangle height, as we want big triangle base is to big triangle height. Now the most common mistake I see you guys make is you say then 12 is to x. We do not use 12, and here is why. 10 is to 5. That's comparing a right triangle. If you use 12 is to x, you're actually truncating that shape and you're comparing a trapezoid. So you can't compare a triangle to a trapezoid. Those aren't the same shapes. But you can talk about the large triangle. So I do need the full base. Well, actually, they didn't tell me the full base. They did give me some information. They told us the 10 and the 12. And together, 10 plus 12 makes a full base of 22. So now I have a base of 22 is to height x. So I do have it matching up base is to height as base is to height. Once you have that, it just becomes a basic cross multiply and divide. And our final answer ends up as 11. Next, we're going to look at our two different triangles here. Just like last time, I have a smaller one inside of a larger one. Earlier, I compared little triangle parts are to big triangle parts. This time, I'm going to set them up in corresponding orders. So, I'm going to say little triangle base is to big triangle base. So, little base is to big base, as my little, we'll say diagonal, is to the big triangle's diagonal. So little is to big as little is to big. Cross multiply and divide, and you end up with 16. Now, just to show that it still could have worked out the same, I could have said base is to diagonal as base is to diagonal. And notice when I cross multiplied here, x times 3 is still the same product there, and we still have the same product here. So you would still end up with 16 either way. So here is our real life scenario. We know that maybe you're standing 24 meters away from this tree, and that tree is 21 meters tall. Now you are 56 meters away from this building, and we want to figure out how tall that building is. So I'm going to set up a proportion, and we'll say base is to height as base is to height. So base 24 is to height 21 as base 56 is to the large building height. So base is to height as base is to height. We cross multiply, we do end up with some large numbers, but the calculator would tell us that is 49. Now, this is real world, so real world should always include units. So down here, it's not just 49, but it is 49 meters. 49 meters. And this next page, this is why this is one of my favorite sections to teach, because we get to draw pictures, and pictures make me happy. So, when you are doing your homework and even your test, I will give bonus for adding super amazing pictures that make me smile and creativity points. So, detail is important and it matters. So here is me. When Miss Duran stands 2 feet from a lamppost, her shadow is 3 feet long. And if I am 5 feet tall in heels, then how tall is the lamp? So, Miss Duran, let's see. Here's me. I've always got a bun in my hair. I usually have some pretty big earrings on. That just kind of makes me look like I have wonky ears. That's okay. So, got my hair. I've got on boots today. Alright, cool. So there's me, and then there's a lamppost. There's lots of different kinds of lampposts that you could draw. I'm going to do the one that kind of kicks out some light like this. Have fun with your lights and your lampposts and your people. So, then we label our information. I am standing 2 feet away from that lamppost. 2 feet. And my shadow is 3 feet long. Ooh. So here's my shadow. And if the light's back here, remember my shadow would be coming that direction, right? And if I am 5 feet tall, then how tall is the lamp? So notice it kind of creates a right triangle within our picture. So we can say base is to height as base is to height. Our smaller triangle, base 3, is to height 5. As larger triangle, ooh, don't forget it's not 2 is to x, it's 5. 3 plus 2, the big base, the full base at the bottom is 5 is to x. Okay, so then we cross, multiply, do some fancy math, and get our answer. That's 8.3 units are feet. Alright, then our next one is Bubba. Bubba walks away from a tree and until his shadow, his head's in line with the top of a tree. On top of the tree's shadow. So Bubba's standing 15 feet away and 6 feet from the end of the shadow. Alright, so we've got a tree. I'm going to start there. We've got a tree. Again, this is where you get to be creative and have fun. We got lots of leaves in this tree. Mine has a spot for a bird. Here's a little, we're going to put a little bluebird in there. With his little feathers. And then we've got Bubba. Now my Bubba is a baseball player. So I'm going to have to make him a baseball player. He's got his bat. And there's a baseball. And we're going to give him a uniform. He's got some pants on, his baseball pants. He's got cleats on. He's got his baseball hat on. He is ready to rock and roll. So, labeling my information. We've got Bubba standing 15 feet from the base of the tree. So right here is 15 feet. But he is 6 feet from the end of the shadow. So from the end of the shadow, there's still 6 more feet. Now remember, he was in line at the top of his head to the end of that shadow there. Now Bubba is 5 feet tall. And we want to know what's the height of that tree. So, staying consistent with what we've been doing, I'm going to say base is to height. Little base is to little height as big base. Ooh, don't forget, big base is 15 plus 6. So the big base is actually 21 is to height there. So then we cross multiply and divide. Do some fancy math. Calculator tells us 17.5, and it's real world, so we need units, which are feet. Last, we've got a mirrors on the ground, 8 feet from Ricky Bobby, and 19 feet from a flagpole. Ricky Bobby, ooh. Anybody ever see Talladega Nights? He is a race car driver. So, Ricky Bobby I'm going to give him his clothes. He's a race car driver, so he's going to have a hat too. I don't know, I think maybe we need his race car. Roll with it. That's his amazing vroom vroom. If you've ever seen the movie, his race car number is 26. Now, he is looking in a mirror on the ground. Here's my mirror on the ground. And he sees a flagpole. Well, it's got to be a Texas flag. So remember, when y'all are doing your notes, doing your assignment, we are looking for some amazing drawings. The more creative you are, the happier it makes me. And then you get bonus. So here's our Texas flag. Alright. Now, Ricky Bobby is, let's see, what color do I want? I did that color here. Alright. Mirror is 8 feet from Ricky Bobby and 19 feet from feet. There we go. 19 feet from the flagpole. And Ricky Bobby is 6 feet tall. How tall is the flagpole? So setting it up consistently again, base is to height as base is to height. Base is 8 of the little one, height is 6 of the little one. Now before, to get the base, we added them together. But the directions this time says that the mirror is 19 feet from the flagpole. So the whole base already is 19. So that's why we're not going to add this one together. And we cross multiply, do some fancy math, and calculator should give you 14.25, and it is units of feet. All right. Y'all have fun, work on your assignment, and that's it.